Hello and welcome to the third video on disguised quadratic equations. Today we're going to be looking at a third example on disguised quadratic equations, and this equation is x to the power 2 over 3 plus 2x to the power 1 over 3 minus 8 is equal to 0. This looks scary at first sight, doesn't it? Because of the powers and whatnot, but if I told you that this is a disguised quadratic equation, this would make it a lot easier. And what do you know? It is a disguised quadratic equation. So how would we solve this? The first step in solving any disguised quadratic equation problem, go to your equation, look at the powers of your variable, and look at the lowest power. In this case, it is 1 over 3. It is x to the power 1 over 3. And then we're going to say that lowest power, we're going to assign it to any letter that we want. In this case, I'm going to pick h, and I'm going to say let h equal to x to the power 1 over 3. What does that mean? That means h squared is equal to x to the power 2 over 3. X to the power 2 over 3. Let me just explain how I got this. For some of you who might be confused, well, h squared is equal to x to the power 1 over 3 squared, which is equal to x to the power 1 over 3 multiplied by 2. Okay? H squared is equal to x to the power 1 over 3, which is this thing, the entire thing squared. Double powers multiply each other. You all know these laws from your IGCSE maths where you learnt about exponents. Double powers multiply each other. So 1 over 3 multiplied by 2 gives us 2 over 3. That's why we say h squared is equal to x to the power 2 over 3. So after having these two conversions here, what are we going to do? We go to our original equation, and wherever we see x to the power 1 over 3, we're going to replace that with h, and wherever we see x to the power 2 over 3, we're going to replace that with h squared. So h squared h, okay? So that becomes h squared plus 2h minus 8. So h squared plus 2h minus 8 is equal to 0. And what do you know? We have a quadratic equation. We have a quadratic equation. Now we want to solve this quadratic equation. Pause the video, try it on your own. You can complete the square, you can factorize, you can use the formula. I'm gonna factorize because product is -8, sum is 2. That's gonna give me 4 and -2. So h plus 4, h minus 2 is equal to 0. So h is equal to -4 and h is equal to 2. These are my two solutions. H is equal to -4 and h is equal to 2. Because I said let h equal to x to the power 1 over 3, if h is -4, then -4 is equal to x to the power 1 over 3. If h is equal to 2, then 2 is equal to x to the power 1 over 3. So if I come here, then 2 is equal to x to the power 1 over 3. Then -4 is equal to x to the power 1 over 3. Okay? Then I want to solve for x. What do? Raise both sides to the power 3. So x is equal to 2 to the power 3 and x is equal to -4 to the power 3. What does that mean? That means x is equal to 8 and x is equal to -64. And these are my two solutions for x. You can confirm them, you can plug in x here, and it will work out. So that is how you solve this disguised quadratic equation. It's quite simple. We've looked at 3 examples so far, and yeah, that brings us to the end of this video. In the next video, in the upcoming video right now, I will be finally explaining to you the theory of it, in the sense that how do we figure out if a particular equation is a disguised quadratic equation or not? Because not every equation is going to be a disguised quadratic equation. For example, if I give you the equation x to the power 4 minus 3x to the power 3 plus 2x squared plus x plus 1 is equal to 0. This isn't a disguised quadratic equation. In fact, this right here is called a quartic equation. Is called a quartic equation, and you know you can't solve this. Okay, it's called a quartic equation. Totally not necessary for you. It's a bit higher level. You can't solve this at all. It's not a disguised quadratic equation. You can't apply these basic principles that we are here to these particular equations. So not all equations are going to be disguised quadratic equations.